Hello, we are going to learn how a galvanometer can be converted to an ammeter by simply connecting a low resistance known as a shunt. The diagram on the board has been carefully drawn to illustrate how that can take place in an electrical circuit. But what I want us to understand is this. There are two devices that can be used to measure the amount of current flowing through an electrical circuit. And these devices are, the first one is ammeter, second one is galvanometer. But our interest here is, how do we now convert galvanometer to an ammeter? And how do we make an ammeter sensitive enough to detect and then measure small amount of current flowing in the circuit? That's our concern, not more. But we must understand something. The sensitivity of the devices in measuring current depends on certain factors. The current being measured must be taken into consideration, the calibration of the material, and so on and so forth. All right, but when do we now say, or how can we say that an ammeter is sensitive? How? Very simple. If an ammeter can measure or detect small amount of current flowing in the circuit, we can now conclude that the ammeter is sensitive. If you can detect and measure it, that shows the ammeter is sensitive. Concerning galvanometer, originally, a galvanometer is known to be a sensitive device that detects and measures small amount of current flowing in the electrical circuits. So we may not have much to say about this, but our concern is, how do we now convert a galvanometer to become an ammeter, allowing it to detect and then measure current flowing in an electric circuit? That's what it means by the sensitivity of the devices in measuring currents. All right? If a device or an instrument for measuring current can detect, after detecting, measures it, gives it a value, that means that device is highly sensitive in terms of measuring currents. With that said, now let's go into explaining what the diagram is all about. All right? The diagram is a representation of a galvanometer with an internal resistance. All right? This galvanometer is expected to give full-scale deflection when current is supplied to it. But there is something that we're about to achieve here, and that's why we have an external resistance known as shunt. What do we want to achieve? Very simple. We want to convert this galvanometer towards an ammeter. Look at it here. How to convert a galvanometer to an ammeter? By connecting a shunt. So this resistance connected in parallel with the galvanometer is so for us to be able to convert this galvanometer towards an ammeter. That's the reason. Now, having said that, the next thing we need to understand is this. What is the function or functions of this shunt? Why shunts? Why not ordinary resistance or resistor offering certain amount of resistances? We will discuss that in the next class. And then, before we move in discussing that, maybe solving some problems in the next class, let us also see how this functions in converting a galvanometer to an ammeter. All right? Before I go into all that details, right? I want to use this moment. Come on. Once again, thumbs up, subscribe. Put on the bell button for constant notification. Share. Keep on sharing. People want this, okay? Thank you. All the same, I want to thank my returning subscribers, my new subscribers. You guys are amazing, highly amazing. Thank you so much. Remain put and make sure you patronize this channel. Having said that, let's see what happens. Look at this. This is all about what the shunt does in the circuit. It's about the shunt. What do we mean by a resistance known as a shunt? Simply, it is a low resistance wire whose function is to divert large amount of current. Okay? Divert large amount of current being measured. That's the first thing it does. Then the question is, why must the shunt divert a large amount of current being measured? For one reason, so that small amount of current will be allowed, or small amount of current will be permitted to flow through the galvanometer. All right? If a large amount of current is allowed to flow through the galvanometer as a sensitive instrument meant to, or rather designed to measure small amount of current, will be affected. So it doesn't need, I repeat, the galvanometer does not need large amount of current that will affect its system. That's it. So that's why we connect a shunt. The function is to divert. A shunt is a low resistance wire designed to divert a large part of the current, yes, being measured. So that's why it's designed that way. After that, after diverting a large part of the current, the next thing, it will allow, or it permits, only small amount of current to flow through the galvanometer. Look at it, G. That's it. So after diverting large amount of current, small amount of current will now flow through the galvanometer, so that the galvanometer will be able to detect it, measure it, and then attain full-scale deflection. We will talk about that in my next class. Come on. A lot of things to discuss here. All right? Then the third thing we must take into consideration is that the shunt must be connected in parallel with G. Look at it. It must be connected in parallel with G. As G stands for Galvanometer. And when that happens, it will be able to divert a larger part of the current, allowing only small amount of the current to flow through. Understand that? If you do, then we will now know exactly how a galvanometer can be converted to an ammeter. That's what the diagram is all about. All right, so look at this. Let's look at the diagram once again as a recap of what I've just said. This is the cell powering the system, right? Once the key closes, current flows. But something happens at this juncture. Not all the total current being supplied by the cell flows into the G. No. What happens is that at this point or junction, the current splits. Small amount of current flows here, I small flows into this. I big, don't mind my word, I'm using I big, that's large amount of current flows into the shunt. Can you now see how the shunt diverts a large part of the current from flowing into this and that only allows small amount of the current to flow into the G. That is it. That's the function of shunt. Okay? And what happens? The small amount of current emerges at this point, and then this large divert emerges at this point, recombine again. Goodness me. Look at it, and it flows back to the source. This is the cell. Okay? That's it. In fact, it's a simple analogy. It's a simple explanation of how a galvanometer can be converted to an ammeter. I want to use this moment to thank you for your patience and watching up to this moment. Don't forget, before I let you go, subscribe. Give us a thumbs up, come on. And then share with your friends, networks, students, and all what have you. Put on the bell button on for constant notification so that each time content like this are uploaded, you'll be among the first set of individuals to be notified. Next, we are going to solve a problem that has to do with conversion of galvanometer to an ammeter. Yes, that's the next class. We are going to learn how a galvanometer can be converted to an ammeter by solving a simple problem that has to do with that. See you in that class. The video will be linked there or somewhere there. I'm canceling out this. Move.